This is a script for case study 5, which is green screen keying. The script has divided into 8 sections. We started from here, then we finished the final output at the bottom of the script. Now let's take a look at the first section, which is a lookup table set up for this project. This name is specific. When the lot is called a viewer underscore input or capitals, then this IP icon will be activated. After the IP icon is activated, the lot is applied to the viewer1 panel. This is a half-floating EXR plate, so that means we have high dynamic range in the highlights. If I temporarily switch off the IP icon here, switch the none from sRGB, this is the default lot applied to the viewer1 panel in Nuke. Through this lot, we can see the highlights are blown out, and here, and also here. If we place the mouse cursor in this area, you can see RGB values. They're all above than 1. This is why the values, especially in the highlights, cannot be properly displayed. However, when we crank down the gain sliders, we can still see all the color information are hidden in the highlights. We need to properly see these color details. A lot which allows these details to show up on 8-bit monitors. Now we can properly see all the color details in the highlights. Section 1, which is to remove film grain from the background image. This is the background image. Okay, we're going to use for the final composition. We don't know what kind of cameras were used for this image. However, we want to integrate this image into the green screen plate as a background image. So the first thing is to remove film grain from this image. After the film grain is removed from the original background image, write it out as EXR sequence. If I do a comparison between the original background plate and the plate with film grain removed, before, after, especially the gray area, it's quite obvious. Because the denoise node is quite expensive to calculate in Nuke, we write it out, then read it in, then start the following operations from here. The second section is mainly about dealing with the background image, because we need to integrate this background image into the green screen plate, which was filmed by a different camera and different lens. That is why we need to remove the original lens distortion from this image, then apply a new lens distortion we calculated from the green screen plate. Because this image will be integrated with the green screen plate, so they must have exactly the same lens distortion information. Then after that, we applied a reformat node, decrease the size from the original, which is 8K, to the format which matches with the green screen plate, 4K DCP. Then after the reformat node, we applied 2 transform nodes. The first node is to reposition the image and lift it up a little bit to match the perspective of the green screen plate. Then the second transform node, from the expression link, you can say it's driven by a tracker node which tracks the movement of the green plate. So we tracked this shot with a 2D tracker, and the tracker was placed on one of those tracking markers, then eventually track the 2D movement. Then use this 2D tracker to drive different elements in the downstream. After these 2 transform nodes, we connected a grid node to color correct the background image. Because this image will be used as a background, so it's going to be defocused. We have a number of tracking markers located on the green screen, even they are autofocus, because of the color variations. If we ignore those tracking markers during keying, we can't really get clean result, especially when those tracking markers overlap with characters. So the idea is to remove those tracking markers, then after that, key the plate. So in this section, as we can see here, before removing tracking markers, denoise the plate. After that, I use a 2D tracker and place the 2D tracker in one of those tracking markers here. I created a roto clean patch close to this tracking marker, pre-multiply it, use a transform node to move the original position to cover this tracker. We do understand there are some movements happening in the shot, so that is why the second transform is set to match move, driven, if you say the expression link, by the 2D tracker, as we can see here, to follow the movement in the green screen plate. After the second transform match move node, this clean patch has been applied on top of this original plate through the merge node before and after. So this is how you can remove tracking markers from green or blue screens. This tracker is relatively easy because we don't have any surrounding elements overlapping with this tracker. However, some other trackers, for instance, this one behind the character, is covered partially by the character. Now let's look at how we can remove a tracking marker like this. I used a rotor node to create a little circle close to this tracker. Then after that, pre-multiply it. Then use a transform node to move its original position to the position where the tracking marker is located. Then after that, another transform match move node is applied. So this is a concatenation between these two nodes. The second transform node is driven by, again, the same tracker node because we track the movement of the plate. Then after that, this clean patch is integrated, as we can see here. This clean patch covers the hoodie, also part of the hair. So that is why you can say we use these two pieces to cover this area through a merge node. We removed the original tracker and we also fixed the overlapping issue. Now, when all those tracking markers are removed in this section, then we can render the green screen plate out without any tracking markers on it as EXR file. Write it out and read it in, so we don't need to repeatedly calculate all those nodes above. In section 4 is about removing film grain. Before keying, you also need to remove film grain. As you can see here, that's the plate without tracking markers. Then after that, write it out as EXR sequence. Then read it in. Section 5 is about keying. Now, we started from here. In this example, we used a pair of IBK keys to generate the mat. As you can see here, this is the initial mat created by these keys. We still have a lot of issues, as you can see here, a lot of holes in the core and here as well. If we increase the gamma, it's not solid, black area. So we need to fix these issues. We started to fill up the black holes for the monitors. The rotor created, you don't need to rotor every single frame. The rotor is only created for one frame. Then after that, you use the tracking data to drive this rotor. That is why the rotor is moving across the entire frame. It's the same operation for this monitor here. Use them to cover the black holes. As you can see here, use channel merge. Usually we can increase a couple of stops for the gamma slider. Want to get them pure black. Use a erode, then blur it. I'm using this alpha to multiply this alpha. If I place my mouse cursor over this area, then you can say RGBA. That is looking really good. Now I'm gonna go back to the normal gamma value. In this section, we used an expression node to remove the green color from the green screen before and after. After this expression node, we used a couple of hue corrector nodes to remove some reflections around silhouette of the characters. We've got a result like this, but the plate is still without any matte embedded. It is time to copy the alpha into the alpha of this plate. Now, if you take a look at the result from the copy node, you can see the matte is copied in, then promote. All these previous operations are serving for one purpose, which is to generate a high quality matte. The matte is the only element I want to use. Then after that, it's time to merge this result on top of this result. Section 7 is to deal with additive care. This is a proper gizmo of the additive care, which has 3 inputs. Click this plus sign. There are a couple of things we need to keep in mind. In Nuke, we deal with linear color space. We need to convert the linear to logarithmic color space, then do the math, as you can see here. That's the final result. After this additive care operation, it is time to reapply the original film grain to the result. Section 8, as you can see, is quite simple. We used an add mix node. We put the foreground on top of the result generated by the additive care. After the initial composition, we also applied a couple of grid nodes then to do the global color grading based on the storytelling.